Hey,
Chemistry.
hey guys, today we have a special guest appearance. Oh, Mrs. Waller was walking by. She had to start her car. Anyways, today we are going to learn about solubility. Earlier in the week, we learned about, we revisited polar versus non-polar things. So I'm going to do a quick demo for you guys so you can kind of see where we're going. So a styrofoam cup is non-polar. And if you put a non-polar thing into a polar thing, nothing happens. It's not very exciting. You got a styrofoam cup floating around. If you put a non-polar thing with a non-polar thing, things start happening. It's kind of cool. So our styrofoam cup is dissolving in the acetone, turning into solution. All right, kind of neat, right? So, swirling things speeds up reactions, and you're left with this globbly glue stuff. You can put another cup in, and it's going to dissolve in there as well. Pretty neat, right? Pretty cool. And then if I want to get my styrofoam back out of it, because non-polar things dissolve non-polar things, and polar things do not. If I want to just take a look at our clear liquid, if I pour polar things in, the styrofoam will come back out of solution. It's pretty neat. So that quick demo is good. Let's hop over to what we are looking at today. So we are learning about solutions. You just saw a solution being made. I am going to constantly just say, oh yeah, likes dissolve likes. Remember, as I write, you guys should be writing things and taking notes as well. Likes dissolve likes. So that's what we're talking about with polar things dissolve polar things, non-polar things dissolve non-polar things. You know, you can think about that as your Italian salad dressing, how those do not dissolve. All right, so a couple quick notes then. When something dissolves in something, we had a liquid, right? That liquid is called our solvent. The thing that you put into the liquid is your solute. All right, and together, those things make a solution. Cool. All right. So we are going to talk much more about this graph as time goes on, but I'm just going to give you the gist of it. So we have a whole bunch of ionic compounds on here. And we can pick on this line. We'll look at KCl. All right, so here's our KCl line. You can see as temperature goes up, our line goes up. It shows us that solubility increases as temperature increases. So look at your units here. We have temperature here. This is grams of solute that can dissolve per 100 grams of water. All right, with that being said, let's go ahead and flip to the back side. So, number one, let's go through a couple of these. I will upload the rest onto Haiku, or not the rest, I'll upload some selected answers up on Haiku with some guided notes on it, and then you are expected to complete the rest. As always, feel free to email me with any questions you may have. So number one, look at the graph. In general, how does temperature affect solubility? So as things get hotter, look at your lines. They're all positive slopes. So what do you think? Easy enough, right? Increases. Let's look at a problem with some numbers. All right, let's skip down here to number 4. How many grams of potassium chloride can be dissolved in 100 grams of water at 80 degrees Celsius? So we have 80 degrees Celsius. We are looking at potassium chloride. and you're just seeing where you hit the line. So all of these have different lines and different slopes. The lines represent you making a saturated solution. Just like I couldn't keep putting in styrofoam cups into that nonpolar solution or solvent, they wouldn't just keep dissolving, keep dissolving. You can't just keep putting Kool-Aid into water and make a really Kool-Aid-y solution. It's, eventually things will stop dissolving. So that's what this line represents, when you can't dissolve any more solute into your solvent. So at 80 degrees Celsius, I follow it up till I hit my line of potassium chloride, which is KCl, and we're going to call that like 50. All right. So I can dissolve about 50 grams of potassium chloride in 100 grams of water. If I was to add any more, the potassium chloride would just sit on the bottom of that cup or beaker. Nothing else would happen. All right, let's look at one more, and then again I will upload some extra hints online. I can't even see how long this thing has been running for. Here, Mr. Bartlett's right here. He's my helper.
Yep, you can see on here it's been going for about 6 minutes so far. 6 minutes, 40 seconds.
You see, I'm wearing this old man sweater, so my mind is kind of going. Anyways, let's look at number 9. Number 9, we are at 60 degrees Celsius. We have 72 grams of ammonium chloride, so that's our NH4Cl. We're going to pour it into some water. The mixture is stirred for a long time. Is this solution saturated or unsaturated? So you go to the front, you find 72 grams, you find your 60 degrees Celsius, and you see where those lines connect. 72 grams, 60 degrees Celsius, 60 degrees Celsius, 72 grams, right? And you look at your NH4Cl line. We are above the NH4Cl line. So what does that mean? Remember, you can only dissolve as much solute as the line tells us. So we could dissolve about 55 grams of NH4Cl in 100 grams of water. So what happens to the rest of it? We can dissolve about 55 grams. What happens to the rest? If saturated, so we are making a saturated solution. It says how many grams are left over, undissolved. So if we could dissolve 55 grams only, but we were trying to dissolve 72 grams, how much is left over? So this just becomes simple, pretty simple math. Do your subtraction, what do you get? So that's how, that's what 8 and 10 are kind of like. The ones at the top are more straightforward, just looking at your graph, pointing at things, and figuring it out. So again, we are looking at solubility. Everything has different solubilities. It's how much chemical you can dissolve in this case, 100 grams of water. That changes with temperature, and it changes with what type of chemical you are looking at. We will talk more about that in the coming weeks. Thanks for watching. See you soon.